Random forest in Python. Random forest in Python, a practical end-to-end machine learning example. There has never been a better time to get into machine learning with the learning resources available online. Free open source tools with implementation of any algorithm imaginable and the cheap availability of computing power through cloud services such as AWS. Machine learning is truly a field that has been democratized by the internet. Anyone with access to a laptop and willingness to learn can try out state-of-the-art algorithms in minutes. With a little more time, you can develop practical models to help in your daily life or at work, or even switch into the machine learning field and reap the economic benefits. This post will walk you through an end-to-end implementation of the powerful random forest machine learning model. It is meant to serve as a complement to my conceptual explanation of the random forest, but can be read entirely on its own as long as you have the basic idea of a decision tree and a random forest. A follow-up post details how we can improve upon the model built here. There will of course be Python code here, however it is not meant to intimidate anyone but rather to show how accessible machine learning is with the resources available today. The complete project with data is available on GitHub, and the data file in Jupyter Notebook can also be downloaded from Google Drive. All you need is a laptop with Python installed and the ability to start a Jupyter Notebook, and you can follow along. For installing Python and running a Jupyter Notebook, check out this guide. There will be a few necessary machine learning topics touched on here, but I will try to make them clear and provide resources for learning more for those interested. So, what random forest is? Random forest is an ensemble technique capable of performing both regression and classification tasks with the use of multiple decision trees and technique called bootstrap and aggregation, commonly known as bagging. The basic idea behind this is to combine multiple decision trees in determining the final output rather than relying on individual decision trees. Random forest has multiple decision trees as base learning models. We randomly perform row sampling and feature sampling from dataset performing sample datasets for every model. This part is called bootstrap. Problem introduction. The problem we tackle is predicting the max temperature for tomorrow in our city using 1 year of past weather data. I am using Settle WA, but feel free to find data for your own city using the NOAA Climate Data online tool. We are going to act as if we don't have access to any weather forecast, and besides, it's more fun to make our own prediction rather than rely on others. What we do have access to is 1 year of historical max temperatures, the temperatures for the previous 2 days, and an estimate from a friend who is always claiming to know everything about the weather. Actual and predicted values. Roadmap. Before we jump right into programming, we should lay out a brief guide to keep us on track. The following steps from the basis for any machine learning workflow once we have a problem and model in mind. 1 is state the question and determine the acquired data. Next, acquire the data in accessible format. Identify and correct missing data points, anomalies as required. Prepare the data for the machine learning model. Establish a baseline model that you aim to exceed. Train the model on the training data. Make prediction on the test data. Compare prediction to no test. Set targets and calculate performance metrics. 9. It performs is not satisfactory. Adjust the model, acquire more data, or try a different modeling technique. And last, interpret model and report result visually and numerically. Thank you.